TOKO bandpass filter coils seemed a bit tough as I am beginning the hand winding of the coils in easy BITX after completing the assembly of other components up to the final MOSFET IRF 510. Discussed with VU to EVQ on 40m and got the advice of winding similar number of turns in each groove of the TOKO bobbin, which has 4 grooves with 36 SWG enameled copper wire depending on the total number of turns needed for each band as mentioned in the manual. VU to SWX shared a web page by VK3PE which gave useful tips for winding as well. These are the devices provided in the kit on which the coils have to be wound. Looks like the IF transformers of yesteryear elbowed radios. Metallic cap was removed and you can see the bobbin on which the wire has to be wound with ferrite core inside. There are 5 pins outside. On one side there are 3 which will be used, and connection will be only to pin 1 and pin 3. Wires in the kit were number 36 and number 28. Obviously the thinner one has to be used for winding these coils. So this is the thinner wire taken out, a nice coil of very fine wire which I'll have to be very careful about while winding. To begin with, I scraped off the insulation on one end and made it shiny so that I could connect it to one of the pins. A few turns of the bare copper wire was wound on one of the pins so that I can solder it. Now the wire has been soldered to the first terminal on the side where there are 3 terminals. Rest of the wire was taken down through the groove on the side to the bobbin where the wire has to be wound. Initial 1/4 of the wiring was done in the first groove and then switch over to the second groove. Winding was then continued in the second groove and later moved on to third and fourth grooves sequentially. After completing 18 turns as mentioned in the manual for 40m, the wire was again taken up through the second groove towards the pin number 3. End of the wire was cut, scraped and then soldered to pin number 3 to finish the contact. Initial testing showed inductance of 1.6 microhenry in my LCR meter, that is without the cap. After placing the cap, the inductance was about 2.8 microhenries, and now I am trying to turn it, that is the central core is being turned gradually. When it is turned so that the core goes inside, inductance is gradually increasing. You can see that it has gone to 4 microhenry, and now I am coming back. It is coming down 3.4. No, this is I tried once again, and now it has come down very minimal inductance up to, it came down up to 0.1. So this is the mechanism of changing the inductance. Again I am increasing, so this has increased up to 3.9, 3.8, and I'll again turn it back to see how the inductance is moving. It has come down to 2. Finally I set it at 2.5 microhenry, which was the recommended value, and this is the tiny screwdriver bit from a multi-bit set which I used. These are the slots on the PCB for mounting the coils, TOKO coils after winding them. This side is for 40m, other side you can see 20m. Now the first coil has been placed in the slot, and that is not all. 3 more similar coils, 1 for 40m and 2 for 20m have to be made. Then there are other transformers on toroids to be wound that I will be continuing in the coming days.